In order to be able to solve absolute value inequalities, you must really understand these three properties. These three properties basically explain to you how to take an absolute value inequality and change it so that you do not have those absolute values anymore. And I would like to focus on the idea that absolute values represent distance. For example, let's say we have a number line with 0 in the center. This is saying x, the distance x is away from 0 on the number line is a units, or just distance equals a. Well, there are two places, negative a and positive a, that are a units away from 0 on the number line. So I will place solid dots at those 2 points, and that's why we have x equals negative a or x is equal to positive a. Now, if you look at this next one, we're saying the distance is less than a. So it's almost, there's my 0, here's negative a, here's positive a. It's almost like saying distance is less than a. I can't reach a units. It's got to be within a's distance of 0 on the number line. Basically, between negative a and positive a. And that's what we have here. X is between negative a and positive a. Now, let's draw this number line a third time. Distance is greater than a units away from 0. Well, that means it's either got to be off to the right or it's got to be off to the left. And we'd have x is either on the left less than negative a, or on the right x is greater than a. And basically, every time you're removing an absolute value less than, you get a compound inequality where x is between negative a and positive a. And whenever you are solving an absolute value greater than number situation, you have these two inequalities separated by the word or, with a less than a negative a and a greater than a positive a. And this third property is the one that is most highly confused and mixed up by students. So I always recommend you first isolate the absolute value by itself before you apply one of these properties, and once you've identified which property, use the pattern that you see here. In this first problem, we already have the absolute value isolated on the left. It's saying the distance x plus 5 is from 0 on the number line is less than 14. Well, that's a little bit harder to picture. But if you say, absolute value less than creates this compound inequality where x plus 5 is in the center, and it gets separated between negative a and positive a, or in this case, negative 14 and positive 14, there you have successfully removed the absolute value, created compound inequality, and now you can just solve it by subtracting 5 from the left, middle, and right, and that will give us negative 19 is less than x is less than 9. And in interval notation, that would be the interval from negative 19 to 9, not including either of those endpoints. In this second problem, the absolute value is not isolated by itself because we've got the 3 out front and the 7 to the right of the absolute values. So we will begin by subtracting 7 on each side, and this will now give us 3 times the absolute value of 2x minus 5 is less than or equal to 12. Now, I prefer to isolate the absolute value directly. I don't like to distribute the 3 in because even though you can, if that were a negative 3, you couldn't. It's better to just think of the absolute values on their own and isolate the absolute value. So in this case, we're going to divide each side by 3 to have the absolute value of 2x minus 5 now is less than or equal to 4. Now we've isolated the absolute value. We have a less than or equal to sign, so we can say 2x minus 5 is between negative 4 and positive 4 inclusive. Now all we need to do is solve this inequality, add 5 to the left to get 1, add 5 to the right to get 9, and we have 2x is between those two values with equal to's on our inequality. And now dividing by 2, we have 1/2 less than or equal to x less than or equal to 9/2. And in interval notation, our solution set is from 1/2 to 9/2 inclusive. And this is actually called a closed interval because we are including both endpoints. The problem before that is considered an open interval because we are not including either endpoint.